Good evening, friends. Today we are going to discuss projection of points video 4. Last 3 videos we discussed projection of points different positions, and today we will go and discuss if the point is there in the fourth quadrant. Okay, so let's start. So here suppose the point is there in the fourth quadrant. So the question is like that. A point D is, so note down question all of you. A point D is below HP 30 mm, below HP 30 mm, and behind, sorry, this is fourth quadrant now. So below HP 30 mm and in front of VP 40 mm, in front of VP 40 mm. So here the point is there. Okay, so the question is once again, the point D is 30 mm below HP and 40 mm in front of VP. Draw its projection. So as per this rule, below HP and in front of VP, the point is there in the fourth quadrant. So this is only pre-planning view. So fourth quadrant. So we know that from here you can see the front view, and from here you can go for top view. Okay, top view. Now if you observe from the front, or before going that, now the point is there in the fourth quadrant means we have to follow fourth angle projection. So as per fourth angle projection, we know that both front view and top view comes below XY. Front view and top view, it falls on below XY. So here directly we can go for solution. XY axis line, and if you observe front view here, it is below XY. Below XY, how much it is there? So the point is here, this gap we can see from the front. So this 30 mm gap is visible. So from front 30 mm gap is visible. Front view where it is coming below XY. So below XY you can take 30 mm. Okay, and here the point. Here point is with the HB pencil. Why? Because it is a solution, projection of points. So the total distance is this is 30 mm. So arrow mark also with HB pencil. So this is a 30 mm. And if you observe from the top, 40 mm gap is visible. It is in front of VP. From vertical plane to this point, the gap is 40 mm. It is visible from top view. So top view also coming below XY. It falls below XY. So already 30 is there. So just you take extra 10 mm. And mark the point. Okay, mark the point. So this is another 10 mm extra. Or separately you can show here 40 mm. So this is front view. So we know that front view show with D means it converts projection, it converts into small letter, and front view shows with a dash, and normal top view shows with normal letter, it is small d, normal d. So front view and top view both falls horizontal plane and also vertical plane, both below XY. And this X and Y also with a HB pencil. This is with HB pencil. After completion of this, you go for given data. This also all we discussed. So the point D is below HP 30 mm and in front of HP 40 mm. You write here. And after completion of this, suppose the question number is, this is 4. Write here question number 4 and go for, this is borderline. Okay. So this is the solution for this question. So question below HP 30 mm and in front of HP 40 mm. So with this first quadrant, second quadrant, third quadrant, fourth quadrant, all we discussed. Now we will go small difference. Sometimes he asks us Suppose the point is there in front of VP, 30 mm, and on HP or on VP, like that questions are there. So how we can answer that we will see now. Okay, so we see here. So this is horizontal plane, this is vertical plane. So here in the previous cases, the above HP in front of VP, the point is there, how to solve that we learned. And now here, what we have to do, suppose the point is there in front of VP, listen carefully, the point is there in front of VP, 30 mm, and on HP. So this is question. Point E is okay. See here question. Point E is in front of VP 30 mm and on HP. In front of VP means this is in front. In front here we can call it in front. But it is on HP. This is horizontal plane. So in front of VP on HP means it is on HP, and this distance shows that in front of VP. How much it is? 30 mm. So 30 mm. So this is the question. So the point name is E. So this is the pre-planning actually. So in front of VP 30 mm and on HP. So how to solve this problem? So once again you go for note. I am writing here note 3. Already 2 notes we discussed. Note 3, what it says? The point is on HP or on VP. The point is on HP or on VP. It falls on XY axis line. It falls on XY axis line. So listen carefully. The point is on HP or on VP. A point is on HP or on VP, whatever it may be. On HP or on VP, it falls on XY axis line. So you must remember this and note down this point. It falls on XY axis line means what is? Suppose the point is there here or whatever, here or here, on HP or on VP, whatever it may be. It falls on XY axis line. How it? That we'll see now. So we go for solution for this. So then easily we can identify. You will get idea. So once again go for XY axis line. Okay. And you are observing front view from this side. Same procedure once again. If you observe front view from this side. So what is there here? There is no chance to see this. Why? Because it is falling on horizontal plane. So how can we draw this? Suppose this is horizontal plane. And suppose it is above HP, it is there. Then if you suppose this is horizontal plane, this is vertical plane. So on HP or from the above HP, 20 mm is there. So if you observe from there, this 20 mm gap is visible. From plane to this object, 20 mm gap is visible. But the object is there on HP. Suppose the object is there on HP. So if you observe from there, so there is no gap between this horizontal plane and this object. So that's why if you observe from here, it falls on, suppose this point falls on where? This is reference line, XY axis line. This is a plane, vertical plane, horizontal plane. Okay. So after completion of the projection, we have to rotate the horizontal plane. If you go like that, this is XY axis line, and below XY this point falls. But if you see this, this point is lying on horizontal plane. So if you project this, what will happen? It falls on the XY axis line. So just it is a constant method. There is no change here. So whenever in examination, if the point is on HP or on VP, like that it is there, blindly you can directly take on XY axis line. It is not. Okay. It is rule. Now, so if you observe here, there is no gap between horizontal plane and object. That's a it falls on XY axis line. Directly you can take on XY axis line. So what is this? Whether it is front view or top view? It is front view. So what is the name of this point? E. So go for small e, and it is front view. So front view show with dash, E dash. Okay. Now go for top view. Now you go for top view. But somebody they will get doubt. This is very very important point. Why? Because somebody says that this point is belongs to first quadrant. No. Somebody says that this point is belongs to third quadrant or fourth quadrant. Shall we go for first quadrant or fourth quadrant? It is also problem. So somebody 50% of the students they will think assume that they are in the first quadrant and they are solving the problem, and remaining 50% of the student they are assuming that the point is there in the fourth quadrant. It belongs to fourth quadrant. Okay, and they are solving the problem. So first we will go for first quadrant. Assume that you assume that the point is there belongs to first quadrant. So as per first angle, first quadrant means it is first angle projection. What is the rule for first angle projection? In first angle projection, front view divided by top view. Okay, is it clear? So front view divided by top view. So if you observe front view, anyhow front view is there. It is on HP means on XY. It is directly we are getting. But if you observe from the top, this gap is visible 30 mm. It is from the vertical plane. Suppose this is vertical plane. In front of VP, 30 mm gap is there. So this gap is visible from the top. Okay. Now, but as per first angle projection, top view comes below XY. So directly I am taking below XY 30 mm. It is top view. So normal letter is E. So this is the 30 mm. Okay. This is 30 mm. Now you see here, on HP means on XY front view, and in front of BP is 30 mm. If you assume that the point is belongs to first quadrant, the solution is okay. No sir, this point is belongs to fourth quadrant. Somebody think that this is in examination. Somebody they are going to solve this point is belongs to fourth quadrant, and you solve this. So what is the rule for fourth quadrant? Both XY, both front view and top view comes below XY. Front view and top view both falls on below XY. So below XY means suppose that front view anyhow it is on XY only. Why? Because if you observe from here, it falls on why it is there on the XY axis line. Directly we can take on XY. On HP means on XY. And if you observe top view, so suppose if you observe top view from this side, what will happen? This gap is visible, but top view where it is there, it is below XY. Automatically we are getting below XY. So in examination, like that any integrated points are there, you can directly assume that the point is there on the XY means the point is there on HP, or VP means directly you can take XY. And suppose the point is there here, you can go second quadrant or you can go for third quadrant. This point is belongs to second quadrant. If you go for solution, you will get exact solution, or you can go for third quadrant also, you will get exact solution. So there is no doubt in that. Okay. Now same thing. I'll go for next question. Suppose this is horizontal plane, this is vertical plane. Now the point is there. So in next question, assume that a point F is above HP. This is above. The point F is above HP 30 mm, above HP 30 mm, and on VP. This is the question. A point F is above HP and above HP 30 mm and on VP draw its projections. So here this gap is given 30 mm. So I am taking 30 mm here. Okay, 30 mm, 30 mm, and draw its projections. So directly you can go for solution. Now tell me, the point is on VP. So what is the rule? Note 3. The point is on HP or on VP. It lies on XY axis line. So blindly, directly you can take on XY axis line. It is clear. Okay. So you should not get any doubt. Just blindly you can take on XY axis line. But how can you identify whether it is front view or top view? So now you go for front view is this side and top view is this side. If you observe from the top, there is no gap between this point and this vertical plane. Suppose I am keeping here vertical plane, assume that this is a vertical plane and this is the object. So the object is not in front of VP, it is on VP. On VP, just directly see here on VP. It is lying like that on VP. So if you observe from the top, there is no gap between this vertical plane and this object. That's why we are directly it falls on XY axis line. Why? Because reference plane is there here. Directly it falls on XY axis line. So directly we are taking here. So front view, it is front view. So what is the point name? F. So here comes a small f. Small f. It is small f. Now tell me, small f. It is front view. Front view means dash. Front view means dash. Next, if you observe from the front, but in the previous case, like the previous case, whether it is belongs to first quadrant or third quadrant, second quadrant, you can assume that any quadrant you will get correct solution. So assume that it is belongs to first quadrant. So as per first angle projection, front view by top view, front view by top view. So front view is over already. Anyhow, not front view. Top view is over. Anyhow, top view is over. Why? Because if you observe from the top, there is no gap, na? So this is top view. So top view means small f and dash, not dash, only normal f, normal small f. It is top view. And if you observe front, this height 30 mm is visible. So but where front view is coming? Above xy. So above xy you take, and this is 30 mm. And this is the front view now, so f dash. If you assume this point is belongs to third, second quadrant also, you will get same thing. Why? Because in the second quadrant, front view and top view both above xy. So once again you are getting front view above xy only. And whatever top view is lying on VP. So directly we will get on xy axis line. It is note 4 as per note 4 rule. So like that, if the point is there in the on HP, either here or here, whatever it may be, wherever it may be. If the point is on HP or on VP, directly you can solve the problem. So like that, 2 to 3 problems we solved on this. So I think that you got a clear idea about this. And last point here in this projection of points, I will give clarity. Another point is smaller. Sometimes in examination, suppose the point is on HP and on VP, draw its projections. Suppose the point is, this is HP, this is VP, horizontal plane, vertical plane. The point is there on HP and on VP, means on HP means on this line, on VP means here. So directly it is on origin. The point G, point name is G. Okay. So assume that it is point name is G. Just write the XY axis line, and if you observe from the front, from this side, and top view from this side. So if you observe top view, front view, there is no gap, it is on HP. So directly you can take point on here, on XY. On HP means on XY. In the same manner, if you go for top view, it is on VP, means on XY only. So here only, it falls on same point. So the point is on HP and on VP, directly you can take on XY axis line. And here front view and top view both this point only. Why? Because on this point only it is falling. So the name is G. So small g, front view dash, and the top view is Z. So vertical plane and horizontal plane. Okay, vertical plane and horizontal plane. is to go through here and go for given data, question number 6 or 5, whatever it may be. So like that, the projection of points, either 1 point or 2 point, whatever it may be. So like that you can solve the problems from projection of points. So with this I am ending this projection of points. If you want any more number of problems from this, so please give me in the comment form. Okay, and please like the video, share and subscribe my channel. So thank you for your support. Okay, thanks once again.